Section 1-2, measuring and constructing segments. Our objective for this lesson is to use the ruler postulate, copy segments and compare segments for congruence, and use the segment addition postulate. First thing, we need to talk about the 4 parts of a mathematical system. Okay, here are the 4 parts of a mathematical system. We'll be using highlighter today. If you do not have a highlighter, please pause the video and go get one. Okay, the first part of a mathematical system is undefined terms. In the geometry system, in our mathematical system, the point, the line, and the plane, point, line, and plane are our 3 most used undefined terms. Okay, there are other undefined terms that we will reference that we don't define in the process, such as like between. We know what between means, we don't define it. On, things being on something else, on or off, those types of things. Okay, so the very first part of a mathematical system is the undefined terms. Next we have our defined terms. Okay, that would be like our segment is a defined term. Array. We'll get into other defined terms such as like a triangle, etc. ... Okay. The next part is a postulate or an axiom. A postulate or axiom is just a statement. We accept without proof. Without proof. We just accept it to be true without having a formal proof. Okay? So if it's just something that what's a postulate or axiom, it's just something we accept as true without any evidence that it is true. A theorem is very similar to a postulate and axiom, except it's a statement that has been proven. So a lot of times, once we take a postulate or axiom, once we prove it and write a proof for it, then we no longer call it a postulate, we call it a theorem, because we've defined it. We have proven it without a doubt, using the rules of logic and proving things, which we'll get to those. Okay, so first we have our very first postulate. So here we start talking about postulate. Okay, the book numbers the postulate. If you see there's a number back behind the postulate, postulate 1.1. That is just a number this textbook gives it to reference it. It's not actually attached to the postulate itself. Okay, it's just a number the textbook gives it. So if you had a different textbook, it wouldn't be postulate 1.1. Okay, so we would call it the ruler postulate. So on the ruler postulate, it says the points on a line. So here, if I have, so let's draw. You'll need a ruler. If you don't have one, pause the video, go get one. Okay. So here we have a line. Now if I had points on this line, let's put 4 points on that line. What the ruler postulate tells me is the points on the line can be matched 1-to-1 with the real numbers. Basically, it's telling me that I can put a ruler or a number line on this line and match up the points with numbers. So the real number that corresponds to the point is the coordinate of the point. So let's say this number here corresponds to 1. That's just what I made it. It could be a 5, it could be a 6. It's just a number line, 1. Let's say this is 2, so then 3 would be in between. This is 4, this is 5. Okay, that's just one way in which I put the ruler on there. So it would be 1, 2. I could have done it and started it at 0. I could have started it here at 5. Okay, but it's just I can put a number line on any line and assign number values to its points. That's all the ruler postulate tells me. Okay, so the real number that corresponds to the point is the coordinate of the point. So here, point C has a coordinate of 4. Point D has a coordinate of 5, so forth and so on. So if I'm looking for the distance between 2 points, A and B, if I'm looking for this distance written as AB, if you notice there is no line above this, If there is no line above it, it is not talking about a segment, it is not talking about a line, it's talking about distance. AB right here is talking about a number, a distance between A and B. Whereas AB here is talking about the segment AB. This talks about a thing, a shape. It talks about the segment itself. This AB is this AB, like that, is a number. It's a distance, it's a measure between two things. Okay, so it's important that we know the difference. This is segment AB, it's talking about a thing, an item. This is AB, this is a number. So since this one's a number, we can use the equal sign on it. Since this is a segment, we don't use an equal sign with it. Okay? Because it wouldn't make sense to say a cat equals a cat. Now, if I had a cat that was 8 pounds and a cat that was 8 pounds, I could say 8 equals 8. Their weights are the same, but I can't say the two things are the same. If that makes any sense. Okay? So I'm looking for the distance between 2 points is the absolute value of the difference. Again, a difference there is a subtract of the coordinates of A and B. So if I want to know the distance between two things, I just subtract their coordinates. Let's say 1 minus 2. But that will give me a negative, so I need to put the absolute value over it to make it positive. So that would make it positive 1. If I want to know the distance from D to B, so I want to know BD, that distance, I would take and subtract the 2. 2 minus 5, it doesn't matter which order you subtract, because if I put an absolute value on it, it's going to make it positive. 2 minus 5 is negative 3, absolute value makes a positive 3. So the distance there is 3. Right, so now first example, measure the length of ST to the nearest tenth of a centimeter. So let's go ahead and let's practice measuring. Okay, just for GP, I'm not going to start at 0. I can start anywhere I want. Let's see. Here I start here at 1. Here it goes up to 6. So this was at 1. This was at a 6, exactly 6 centimeters. So tenth, I don't have to worry about that whole tenth business because it's exactly. So if I want to know the length of ST, which we'd write ST without a segment sign above it, it would equal subtract the 2. Doesn't matter which way you subtract. I'm going to go to the 6 minus 1. So the length is 5. It says to the nearest tenth, so we better put a tenths place in there. Science, significant digits, 5 centimeters. Okay. All right. Now we're going to be doing a construction here next. So you should, again, always already have your ruler, but you also need a compass. If you don't have a compass, pause the video and go find one. Okay, Miss Neal, your teacher has some. I believe there's also some in the library. So you can go ahead and go find yourself a compass. Here's what mine looks like. Okay, you might have a metal one or so forth. You just need a pencil and a pokey spot and a hinge in the middle. Okay. So construction. What construction is? The construction is creating or drawing figures using only a compass and straight edge. You notice how I called it a straight edge and not a ruler? Because our big rule of construction is there's absolutely no measuring. And you've learned in science, whenever you measure, you always have that degree of error depending on what units you're measuring with. We don't want to deal with any of that degree of error. So when it comes to construction, geometry constructions, building something, it's really building. We draw these figures using only a compass and a straight edge. So don't use the measures. We're just using this as a tool to draw straight lines. Okay, so let's do our first construction. So our first construction is going to be copying a segment. So first things first, I'm going to draw a segment to copy. So let's just go ahead at random. Again, I'm not measuring. At random here, let's call this segment A, B. We want to copy that segment. So how I start is I start by just drawing a line. slightly bigger, make it bigger than AB. So then I'm going to copy, first thing I'm going to do is I'm going to copy point A. I'm going to put it down here. Since this point is a copy of this point A, I'm going to put an A on it with a little notch. We read that as A prime. That little notch thing is a prime. That just tells me this is a copy of A. There's A prime. Now I take my compass and I measure the length of my original segment. I do that by setting my point on A and my pencil point on B. So I know this distance right here is the length of segment AB. So now I come and I move my point from A to A prime. And I take it and I draw an arc through that line I've drawn. So now this distance from A to B is the same as this distance from A prime to this mark. So then this mark now, put a dot, is where my B prime is going to go. So then I don't need any of this line. You can't erase it. I normally just kind of leave it. So these two segments I know now are exactly congruent. I didn't measure them. Okay, they're exactly the same. We didn't talk about congruent. We'll talk about congruent here in a minute. Okay, they're exactly the same length, everything. I don't know that length, but they're the same length. Okay, so now congruent segments. Now we get that idea on congruent. Line segments that have the same length are called congruent segments. Okay, you can say the length of segment AB is equal to the length of segment CD. Or you can say AB is congruent to CD. This right here is the congruent symbol. Okay, so I would write AB. The segment of AB that we drew up here is congruent to, so an equal sign, the curvy sign up top, to A prime, B prime, and then again, a segment above it. Okay, so when I'm talking about objects, again, a segment is an object. When I'm talking about an object, like a segment, I need to use the congruent sign. Now, if I was talking about just their measures or their lengths, I could just write AB with no segment sign above it. Again, then we're talking about the distance. So I can use an equal sign. So I would say then AB is equal to A prime, B prime. This is saying the two figures are congruent. This is saying these two distances are the same. So I can use an equal sign there where I can't here. Okay. All right, so let's go ahead and let's do example 2. Here we're going to plot some points and determine whether two segments are congruent. Plot J, which is at -3, 4. Again, you have to go over first before up. -3, 1, 2, 3, 1, 2, 3, 4. There's J. K is 2, 4, 2. There's K. Again, we want to label those points. L is 1, 3 over 1, 1, 2, 3. M is 1, -2. Oh, L, M. Then determine whether segment JK, so let's draw in segment using my ruler, segment JK. Oh, lost it. Okay. Is congruent and segment LM are congruent. Okay. So first here, you notice we're over 2 here. Here we're back 1, 2, 3, so that's -3. So that distance there is 1, 2, 3, 4, 5. That distance is 5. So the distance from J to K is equal to 5. Do you notice no segment sign above it? Because I'm talking about the distance from J to K. Now let's use the distance from L to M. L, 1, 2, 3, 4, 5 is also 5. So they have the same measure, they're the same distance, so they're congruent. So I would say JK segment congruent to LM segment. All right, we have one more postulate and one more example, and then we're good to go. Here's our segment addition postulate. So the segment addition postulate tells us that if B is between A and C, so if I have a point B and it's in between A and C, okay, so let's go ahead and let's draw that. So here's A, here's C, let's put our B in between. Okay? If B is between A, C, then AB, that's the distance from A to B. So this distance plus this distance equals the whole distance. Again, but for something to be in between, it has to be on that straight line in between. I kind of drew it a little low. So what the segment addition postulate tells me is if B is between A and C, then this piece plus this piece equals the whole entire thing. Okay? We can always also do it the other way around, is if these two pieces, this piece, A to B, the one part of the segment plus the other part of the segment equals the whole segment, then I know B has to be in between A and C. Okay? So here, example 3. We want to find D to F. E is between DF, so I know if I take DE and add EF, that gives me DF. Well, D to E is 23, plus E to F is 35, so that would equal DF. So 23 plus 35, 8, 3, 4, 5, 58 is DF. Okay, so now here we want to find GH. So I'm trying to find the one piece. Well, we know FG plus GH equals the whole thing, FH. We know F to G is 21, plus G to H, we don't know that, so I'm going to put a little X in there. F to H is 36. So I would just need to subtract 21 from both sides. So then my X, which is my G to H, would equal 36 minus 21, 5, 15. G to H is 15. Okay. Now, very last example, the cities shown on the map lie approximately in a straight line. So here's my cities. We've got Lubbock, Tulsa, and St. Louis. Find the distance from Tulsa, Oklahoma to St. Louis, Missouri. So we're looking for the distance from Tulsa here to St. Louis. We know the whole distance here is 738. So this is the piece we're looking for. I'm going to label it as an X. Okay, it's kind of hard to see. Let's grab a pen instead. This is my X. We're looking for this distance right here. Okay. But I know that this whole thing is equal to the sum of the two pieces. So I know if I take LT plus TS, it gets me the whole thing, which is LS. Well, we know L to T is 377. T to S is what we're trying to find. We'll label that as X. L to S is 738. So I would just need to subtract the 377 from both sides. So X would be equal to, let's see, we can grab a calculator to do that one out quick. 730, 738, oh, it's not working. Well, here, we can do it longhand. 361, and we're talking about miles. So the distance between Tulsa to St. Louis is 361. Again, don't forget your units, miles. Okay, now I have some your turn problems. There are 4 your turn problems here on the back. I want you to do those 4 problems, okay? Double check them with your teacher before getting started on the practice. You want to make sure that you have a good start before you do any practice. Good luck.